Suppose that a chewing gum company claims that 94% of dentists recommend their chewing gum. Trey wants to test if this is true. He surveys 98 dentists. Assuming the chewing gum company's claim is true, what's the probability that fewer than 89% of dentists surveyed recommend the chewing gum? So this is the same thing as other examples in this section, but the problem is getting right to the chase. It's not first asking us to construct the find the distribution. It's not having us find the z-scores first. We still need to do those things, but it's just not part of our answer. We just need to give the final answer, okay? So the first thing we need to do when we look at this is we need to say, you know what, we're dealing with a sample proportion here. We want to see the probability that we get a certain kind of sample proportion, so we are dealing with a central limit theorem for proportions. And we know that the central limit theorem for proportions has the distribution of sample proportions normally distributed with a certain mean and a certain standard deviation, where the mean is the same as the population proportion, which in this case, we're assuming the claim. So we're assuming the population proportion is 94%. And the standard deviation of sample proportions, which would be square root of p times 1 minus p over n. And just to clarify, this is the population proportion p. So we're going to plug in square root of 0.94 times 1 minus 0.94 divided by our sample size n, which in this case is 98. Okay, so let's start off by plugging that into our notebook, because that's going to be an important part of what follows. Okay, so our population proportion, I'm going to store it in here just so we have a reference. Our population proportion was 94%. All right, let me double check that. Yeah, 94%. And then sigma sub p prime is the square root of p times 1 minus p divided by my n, which is 98. Okay, notice that I could use p when finding my sigma p prime because I'm storing 0.94 in variable p. And so it makes it a little bit more readable. If I want to, I could also store 98 in n, and then I could make the denominator here just the variable n. Okay, makes it a little bit more readable, I think. So let's see what that is. Okay, so I'll just write it one more time so we'll print out. We have 0.0239. So sigma sub p prime is about 0.023, well, I guess 0.0240 if we round. So our distribution is, we have a normal distribution with mean 0.94. And we just found the standard deviation of the distribution is 0.040, about. I'm sorry, 0.0240. Okay. Now that we know the distribution, we want to find the probability by first converting our value to a value in the standard normal distribution, and then use the p-norm function, right? So we want part one here, assuming the chewing gum company's claim is true, what is the probability that fewer than 89% of dentists surveyed recommend the chewing gum? So we want to find the probability that our sample proportion would be less than 0.89 or 89%, assuming that the actual population proportion is 94%. Okay, so our z-score is going to be p prime minus mu sub p prime over sigma sub p prime. Remember that mu sub p prime is just our population proportion p, so I'm going to have 0.89, the boundary value I'm interested in, minus the population proportion, which is 0.94, divided by the standard deviation, which is about 0.0240. Okay, so that's going to be my z-score. So go here, my z-score is going to be 0.89 minus the population proportion, p, which is 0.94, or I could just plug in p because I have that stored in that variable, and divided by the standard deviation, which is about 0.0240, or I could just use the variable sigma sub p prime. Okay? So that means my z is negative 2.08. Okay? So now that I have that z, I can find the probability, right? So I want to find, in my case, whoops. So we're saying the population proportion, we're assuming that it's 0.94. We want to find the probability that we get something less than 89%, 0.89. So we want the area over here. So we're going to use p-norm. We found our z-score. We stored it in the variable z, so I could just plug in z. And lower tail is going to be true. Lower tail is going to be true, right? Because we want to find the probability that we get fewer than 89%. We could see right here that our lower tail is shaded. So let's run that. There we have it. That is our probability. Okay, so let's copy and paste that in. Notice we don't have anything to submit for step 2. So let's go ahead and submit what we have, and then we'll take a look at step 2 and try to understand what's going on. Okay, good, we have it. So step 1, we have it. So we definitely have the right answer for step 1. So the probability that we would get fewer than 89% of adults in our sample, or fewer than 89% of dentists in our sample that recommend the chewing gum, assuming that in actuality 94% of dentists recommend the chewing gum, there's only a 1.857% chance of that happening. That's a pretty low chance. The question in part 2 is, if Trey does find that fewer than 80% of the dentists surveyed recommend the chewing gum, would you doubt the chewing company's claim? Why or why not? So again, this one that we will consider on our own. We won't provide an answer here. We will learn later in chapter 6 how we can be more careful about analyzing this question. But right now, just think about it. So we get 1.857. So that means if the population proportion, and let me write it in terms of problem, if 94% of all dentists recommend the chewing gum, then there is only a 1.857% chance that we randomly select a sample of dentists where only 89% of the dentists in the sample recommend the chewing gum. Okay, so if this really is the population proportion, then the chance that we get the sample we do is really small. Only a 1.857% chance of getting a sample with this sample proportion. Okay, so if we look at that, we could say, well, gee whiz, are we really lucky? Or do we begin to doubt this conclusion here? Do we begin to say 94% might seem a little high? Maybe we actually think that the population proportion is closer to 89%, what we got from our sample proportion, because this is so unlikely a result. The result we got is there's only 1.857% chance of getting results as extreme as the one we got. So we might look at this and say, I doubt the chewing gum company's claim. I don't think it's true. Okay. You may also look at this and say, 1.857%, that's a low chance, but it's not like crazy low. It's not like impossible. So maybe you look at that and say, well, maybe there is still a chance. I'm going to give that chewing gum company the benefit of the doubt and not conclude that their claim is false right off the bat. Okay. So that's what the last part's asking. Look at your result and then decide, gee whiz, is this claim still make sense? Do we still think that this claim is true? Now, at this point, it's a judgment call, but as I said, later on, we will be able to more carefully think about those conclusions and decide them in a more rational basis.